Hello, welcome to my channel. Today we'll be discussing about Unique ID generator. So you might be wondering what is Unique ID generator and why do we need it? So in general, when we use a relational database and let's say we're inserting a row, so in a table we kind of define a column as identity column and primary key, and database is responsible for assigning a unique ID for all the new record that we insert, right? This works very well if we have one centralized database at one place. But as we think about building a system at a global scale, a single database solution will not going to work, right? So to handle that, normally what we need to do is have multiple databases, and we should be able to insert on all the databases independently. Now the issue with that system is that if we are generating a numeric ID, then there will be a collision because two different databases will generate the same ID. And when we are syncing to make it data available across the different databases, we'll have a syncing issue, like a duplicate ID issue, right? So to overcome that, normally people come up with the different solutions. We'll look at each one of those and we'll see the problem that this design is trying to solve. So these are the requirements. One, I need ID to be unique and sortable, right? That means I should be able to sort, and it should be numeric, ordered by date. And another requirement is we should be able to generate a 10,000 unique ID per second. And one of the requirement is that this ID should not collide, right? So it has to be unique, even though it's getting generated in a different server. The ID should not be same. So that's a problem we're trying to solve here. So one of the solution, a quick solution you can think of is, okay, I'm going to have two different databases and we can insert rows in both of these, but database one will generate all the unique IDs, all the unique odd numbers, and database two will generate a unique even number. So in this case, what happens is when these data get synchronized, we do not have a duplicate ID because clearly one database is generating odd numbers, the other database is generating even number of IDs. The problem happens is when we are trying to add or remove servers, right? Let's say we want to have another database here, and we want to have that database also generating a unique ID. That's not possible, right? It's kind of hard to scale. And there are again another solution you could do. For example, you can say this database will generate ID starting from 1 billion. This will start from 2 billion. The other database will start from 3rd billion. But the problem is, again, one of the database might be getting too many rows and may run out of these all the IDs, right? So let's look at another solution. This is basically a unique identifier. So unique identifier is basically 128 bits long alphanumeric value, and GUID is basically you can assume it will be always unique. So it will be always unique, even like you have 10,000 servers. If each of these servers generating a unique ID, they will not be same. That's guaranteed. The only problem is it doesn't fit with our requirement. We wanted it to be numeric and we wanted it to be sortable. But the GUID is none of those. GUID is like, yeah, GUID is unique, but it's not sortable in terms of time, right? Because it will be sorted based on alphanumeric values that it holds. Now, the other solution is a MongoDB object ID. This is perfect in the sense it is time sortable. The only problem is we want our ID to be 64-bit, and this is 12 bytes, 96-bit. Other problem is if you are using a MongoDB object ID, you need to have a MongoDB deployed on as a part of one of your solution, giving you a unique ID. So that doesn't make sense, right? Just for ID to use a MongoDB. The other solution is having a ticket server. So you can imagine ticket server is a centralized server responsible for giving a unique IDs. So all the servers that needs the new customer ID, they will ping this and get the unique ID and then update the DB. The only problem is this is a single point of failure, and it can also become a bottleneck when we are thinking of scaling across. And again, if you have multiple ticket servers, there is no guarantee that they will generate a unique ID on its own. This solution is Twitter Snowflake. We'll look into this. This solution is developed by Twitter, and this kind of uh, matches our requirement. Let's look at how it is. So it's a 64-bit int, long int. The last bit is unused. 41 bits is used for timestamp, and the rest 10 bits is basically for the machine identification. And machine identification is data center ID plus the machine ID. And then we have 12 bits numeric values. Basically, it will start from 1 to 4096. Again, it will go back to 1 to 4096. But we also have a timestamp here. So timestamp kind of guarantees that these IDs are unique. And then we also have these numbers. So combination of all of these gives us the unique identification, a unique ID. Though I won't say it's a problem, but this mechanism gives you, at least for 69 years, your ID will not collide, right? Now let's look at another solution slightly better than this. Before that, let's look at the code, very high level code. In my last slide, I have a link to GitHub where you can go and look at the code in detail. The thing that I just want to talk about is the current timestamp. So once you have the current timestamp, basically you take the current timestamp and shift it by 22 bits, right? So we have like 12 bits for machine and 10 bits for these. So the number of bits 10 plus 12. So you shift 12 bits to the left. Then you take the node ID, that will be like a 10 bytes. That's a data center plus the computer ID. Shift uh, 12 bits, and then you basically assign the remaining bits. You assign the sequence and return the ID. So this way, like you can write your own ID generator that will be guaranteed to be unique. So the other solution that I was talking about is Twitter is Snowflake, and what it is basically it uses 39 bits for the time in the unit of 10 milliseconds. So Snowflake is for 1 millisecond, and this is 10 millisecond. The Snowflake uses 41 bits. This uses 39 bits, and then we have 8 bits for sequence number and 16 bits for machine ID. So this kind of gives a combinations of unique IDs that can go up to 174 years. So you can use either of those solution. Now there are a couple of things to consider. Basically, clock synchronization. So imagine if you have, let's say, 500 machines generating the unique IDs. You have to make sure, one of the problems is to ensure that the clock tick on all the machines are exactly same and they are synchronized, right? You want to ensure that. And high availability and the offline scenarios. So offline scenario is something like, let's say, for example, you have a app running on your phone and you're trying to, insert a row locally. So you need to get the unique ID. But let's say if the internet is not available, how could you do that? In that case, you can imagine your app, whenever it is connected, it kind of fetch the 100 IDs, store it locally, and uses that first. And once you sync up, it fetches the next 100 IDs. So basically, then your app continues to work even though the ticket server, basically the unique ID server is offline, or you are unable to connect for whatever reason. Okay, with this, let's go to the last slide. These are the some of the GitHub links and blogs where you can read more about those unique ID generations. Okay, thanks a lot. Bye.